called this talk Delivering on 2 degrees centigrade. I have various titles. This is probably my most mundane of the titles, I think. Just evolution or revolution. And evolution, I mean incremental change, the sorts of things that we haven't achieved, but we've been talking about. And revolution is something much more fundamental in how we change our society to reduce emissions. Ultimately, I think if we don't do that, it's revolution anyway, because I think 4 degrees C is revolution. So it's a revolutionary different future, either through mitigation or through adaptation or suffering the impacts. And for those who are interested, I have one of those modern fangled Twitter account things and a website where these slides and other things that I write are available. I'm going to start off with a conclusion because I always get told my lectures are quite depressing. So I'm going to try and be a bit more upbeat. And this will be the final slide you'll get today. And this is taken from a paper that I wrote with my colleague, Alice Bowes-Larkin, a few years ago. And I was surprised it got through peer review in a Royal Society journal. And this was put in actually in that paper. This is not a message of futility, but a wake-up call of where our rose-tinted spectacles have brought us. Real hope, if it is to arise at all, will do so from a bare assessment of the scale of the challenge we now face. I think so far we've been very reluctant as a society to recognise how challenging what we are facing is, and we have so far really been putting our heads in the sand and not been approaching the challenge with any degree of, I think, rigour or honesty in many respects. I'm going to start off with a bit of context here, and I'll look at the UK. I come from the UK, so I apologise, some of the examples will be UK-based. The UK makes a claim, it makes lots of claims, and this is about as inaccurate as all its other ones, that it is a leading nation on climate change. Certainly rhetorically, in terms of the language you use, it is doing very well, but it is really struggling to put that in terms of action. Now, it is important to have the rhetoric as well, but we are a long way from bringing about any significant change. But I think it's important there to think of the UK here as a leading nation, and what is it doing? Well, it's got significant tax breaks for shale gas, of which 75% of the weight of the mass of any natural gas is carbon. So when you burn it, you get copious quantities of carbon dioxide. There's a proposed plan for 30 new gas-fired power stations without any carbon capture and storage. We've had the highest investment ever in North Sea oil, not last year, the year before, and the year before that. We're opening 3, might be 5 actually, they're quite small Scottish coal mines. We're expanding aviation and ports. The EU, the legislation on cars has been significantly watered down, and the UK government has not fought hard against that. The UK is quite keen to support Arctic exploration, provided it uses our expertise from the North Sea. And we've also opened up a consulate in Alberta, which you would never do unless you were trying to sell your expertise into the tar sands, the dirtiest of all fuel pretty much, makes coal almost look clean. And we've opened up a consulate so we can sell our expertise to do one of the most polluting things on the planet. And this is from a leading nation on climate change. Let's think of India and China. I'm just going to put these in because they're a different context. By 2020, India's emissions and India and China's emissions, and obviously dominated by China, but India's emissions are also quite significant. They'll probably be somewhere about 50% of what we're emitting today. So just from those two countries, very populous countries, by 2020 there'll be about probably 2.5 billion between the two of them, not far off it. 2.5 billion people emitting about 50% of global emissions by 2020. There's almost certainly going to be in that sort of order of magnitude. They will peak emissions at the very earliest by 2025 to 2030, and that's what they're saying, particularly China's saying could do 2030, India's saying later than that at the moment. Their population will be about 40% of the global population, but their income per capita is much, much lower than the OECD. So it might be high for some people in Shanghai and Beijing, but their income per capita is much, much lower than ours. And they have quite successfully growing economies. So there's real scope for them to actually increase their income, their consumption, their well-being, and that will mean massive increases in their carbon dioxide emissions. They're not looking to saturate in their energy consumption like we have to some extent in the West for a long time to come. So there's some global context. So you put this together, and I think the IEA, the IEA's view, the International Energy Agency's view, is actually fairly accurate. That if we look at this CO2 data, it's perfectly in line with a 6 degrees C temperature rise by the end of the century, which would have devastating consequences for the planet. Now, you have to be careful not to use too much precision in climate change, particularly on the sort of things I look at, carbon budgets and temperatures. Whether it's 4, 5 or 6, what it's saying is a very high temperature change from where we are today, and as Eric was pointing out earlier, a very different place to live, a different planet in effect. Also, this is taken from the newish president of the World Bank, Jin Yong Kim, And he was saying that at 4 degrees C, there will be water and food fights everywhere. And I don't think he means custard pies and throwing water bombs. I think he's actually meaning, actually looking at each other and shooting each other and killing each other. That's the sort of world he's looking at 4 degrees C. So that's where we're heading at the moment. It looks fairly clear about that. My conclusion is much more optimistic, but and I still think we have this choice. I don't think we will succeed here. I think we will fail. But I'd rather us to fail whilst we try. But we have that choice at the moment. It's not set in stone. That we could avoid the 2 degrees C characterization of dangerous climate change. That is a feasible goal of our international community, and it is just. I mean, we're on that sort of margins one way or the other on this at the moment. And I mentioned this the other day when I spoke, and I think with economic benefits, but not with financial benefits. And I'm wrestling economics away from this group of people over here. Economics from the Greek root, which is the stewardship of the household, the prudent use of resources, no reference to money or wealth. That's the old form of it. Political economists worked in this world, a world that's much richer, much more attuned to how we live our lives. And these are the finances that brought Iceland's banks and the UK's banks and many other world's banks collapsing. And these are the ones that are dominating the instruments that are being used on climate change at the moment, the financiers. Climatistics is the making of money, the acquisition of wealth, variously defined like that in the dictionary. And I think that you cannot reconcile with this, and this one actually goes hand in hand with it. So let's think about the industrialized world. What have we signed up to? Well, we've signed up to the Copenhagen Accord and basically every other great international convention that's come out since then, right up to the Camp David Declaration, Warsaw, Lima, and so forth. And they all sign up to something similar to this. This is the sort of statement that we sign up to. And we have this probably in Iceland, but certainly in the UK and in the EU, this sort of language is enshrined in domestic documents as well. To hold the increase in global temperature below 2 degrees centigrade, below doesn't say a 50-50 chance of, and take action consistent with science and on the basis of equity. And actually the sorts of jobs that I do is to really take that and translate what does that mean quantitatively, and then how can you play that back in terms of what that might look like in the forms of policies you might have to deliver in terms of mitigation rates, reductions in carbon dioxide. So for mitigation, the question really is fairly clear, at least if we're honest with ourselves, if our policymakers are being honest to the rest of the world. What CO2 reductions give a good chance of staying below 2 degrees C? That's what we really need to ask from that statement. And for adaptation, if we fail, because it's there's a small chance, about 99.9% chance that we'll fail, but there's a point, one in there that we may succeed, and that's our choice. And what temperatures or climates would different nations have to prepare for? And now the mitigation one, 2 degrees C, I mean, that's a global issue, but actually the impacts play out much more geographically. So quite how that plays out for different nations, if you fail at 2 degrees C and you're at 3 or 4, is something we'd have to find out, and there's obviously expertise that can guide us on that, but I think it's something we will find out as time progresses. So how consistent are these two futures that we hold together? We are aiming for 4, and all of us know that, and yet we're promising ourselves, our children, and particularly the poor people in other parts of the planet, that we're going to aim for 2. So there's a real dichotomy, duality, or hypocrisy, however you may look at it, related to these. So this is a plot. I'm just going to go through this one quite quickly, not in detail like I did the other day, but it's a plot of our emissions up the side for fossil fuels and cement, and the years out along the bottom. This is when we set up the IPCC and the first rigueur event, and this is Copenhagen and the second rigueur event. And you can see emissions have gone up very significantly in that period of time. And they're going to continue to rise. They're growing at about 3%, just under 3% for CO2 at the moment. There's no real sign that's going to go down unless we get an increased economic recession, contraction, or slowdown, but it's likely it's going to go the other way, actually, if anything. So what are future emissions? Well, there are lots of reasons why we think it's going to move somewhere like this. For those that are familiar with the scenarios, that's about A1FI or RCP 8.5. It's just above the highest ones that the IPCC consider, which is slightly strange, because usually scenarios, which I do a lot of work on, you would normally have a plausible range that goes above your business as usual. But the ones we actually have in the IPCC, the highest one they have is actually at about business as usual, which, and that was the same for the last set as well, which is a systemic bias. And that's about, well, it depends how you play out the budgets on this, but something like a 4 to 6 degrees C temperature rise towards the end of the century. As I say, lots of caveats have to be associated with these numbers. It could be a bit higher, a bit lower, it could be a bit later, a bit earlier. And that's something like the 2 degrees C one. So there's a huge void between here. This is the size of our well, whatever you might call it, our lie, if you're being direct about it. You know, this is what we say we're going to do, and this is what we are doing. How do we bridge those two? Well, the orthodox view of it, I'm taking this partly from the UK here, but also from the EU, but this sort of language is used repeatedly. And then in the recent report by a new organisation that Stern's involved with lots of other international economists called New Economy, New Climate, I think, they make same sorts of statements. This is from the UK's Committee on Climate Change, an independent committee from government, in part anyway. To keep global average temperatures close to 2 degrees C, the UK, and indeed countries like Iceland and the other wealthy countries would have to follow suit, needs to reduce emissions by at least 80% by 2050. And the next bit, of course, is essential. Otherwise, will not get published if the governments are going to be spending the money on the publications themselves. The good news is that reductions of that size are possible without sacrificing the benefits of economic growth and rising prosperity, where we're all for that motherhood and apple pie. And you find this repeatedly in climate change statements now. And I find this really quite disturbing because arguably there's some maths behind this, but there's not behind this bit here. This is taken from an EU report, quite an influential report, which came out in 2011-2012, where we were pretty much at this, we're above this concentration for CO2e. A low stabilisation target of 400 ppmv CO2e can be achieved at moderate cost and a high likelihood of achieving this goal. I know the authors of this well, I've worked with them, it's rubbish, they know that as well. But you've got to produce something that is politically palatable. So whilst the content of a lot of these reports is really worth reading, often the conclusions are incredibly misleading. And I can go on report after report where I've engaged with the scientists that have been producing these reports, and that is the case. So I've been discussing this with scientists for at least 10 or 12 years now, and have a reasonable good catalogue of it, but I don't name them too often. An alternative take, which came out of the paper we published in 2011, and which we're reviewing again now with the newer data from the IPCC and Working Group 1, is that if poorer nations are to have emissions space within a set carbon budget to enable them to have near-term development and welfare improvements, that basically means that the poorer parts of the world will be able to have greater access to fossil fuels, because in the short term, that's the thing that they know increases their energy supply, and the energy supply links very closely to their welfare in the short term. It doesn't for us anymore. The more energy we consume, our welfare doesn't go up. Well, virtually any indicator shows that our welfare doesn't improve, but it does improve for the poor people. And if you take that view, then for wealthier nations, our argument was that it's difficult to envisage anything other than a planned economic recession. And we were told, could we not use some nicer language for that, like contraction or degrowth? Well, say it however you want. Whatever word you particularly like, substitute for recession. But we all know broadly what that means. Being compatible with stabilisation at or below about 650 ppmv. And we recently this on the new IPCC budgets, but that's something like a 3 and a bit 4 degrees C temperature rise. So that means that if we are going to have the poorer parts of the world improve their welfare in the short term, we would have to reduce our levels of our levels of energy consumption. And probably in that sense, that will mean in the very short term, that means probably our overall consumption, the size of our economy. I mean, the bankers have been doing this for the last quite a few years. So there's nothing new to this. We have been successfully achieving this in the West for probably 4 or 5 years now. And you have to do this at least until you get low carbon energy supply in place. Once you've got low carbon energy supply there, you can consume as much energy as you want. I mean, there are sustainability concerns that might make it not very viable. From a carbon perspective, we don't really care as long as it's zero carbon or very nearly zero carbon. So the curve for 2 degrees C looks something like that. And what I was saying is that this section here is too early for supply. You can't do it with low carbon supply, with wind turbines, tidal bollard schemes, geothermal. These things you cannot build fast enough. And so you have to reduce your energy demand. Now, they are really important, those technologies. They're a prerequisite of actually achieving a lower carbon, much lower carbon future, but they will come later. So we need to be starting putting these things in place and starting to build them now, but they take a long time. And that's not just, of course, not just about the technologies like power stations, but also things like tram lines or train lines or electric bus routes. Those sorts of things take a long time, those infrastructures, to get in place. Now, these are really different interpretations from the same science. We use exactly the same science. We use basically Gavin's and others people to work. Working Group 1 type work and Gavin's that work. That's a science that Hadley Centre in the UK. We use the numbers that come out of their analysis. We use that, and a lot of the other people are using that, writing these different reports. Yet we're saying you can't have economic growth and hold to the targets that we've signed up to. And others are saying there's no problem. You have prosperity, motherhood, apple pie, and meet your targets. Now, there's something different. What's happening? Why are these different interpretations from the same science? This is slightly out of date, and I need to upgrade some of it. I tried to tweak it last night with the best data I could get, but nonetheless, I think it gets the general point across. And this has been happening for at least 15 years, if not longer, what I'm going to try and show here. This is annual CO2 up the side, again, and dates from 2000 out to 2100 out the bottom. And what I'm thinking, when you think about this, what really matters when we try to make assessments via the carbon budgets of what it is we need to do? Well, first you have to ask, what are current emissions? That's not an unreasonable question to ask. And you assume we'd all get the same answer for that because the data is available. And we all use the same data sources. What growth rate would you see to the peak in emissions? When do we think the peak in emissions is going to occur? What's the reduction rate that is viable once you reach the peak and come down? Is there an emissions floor? I'm not going to talk about that today, but that mostly relates to things to do with food production, primarily food production, methane, and various oxides, nitrogen, and so forth that end up very hard to remove. So you always have something out here. Are negative emissions assumed? Can we suck the CO2 out of the air with geoengineering? What's the total budget that we're using? So these are questions we need to be asking ourselves as to why it is we're coming up with different conclusions. Now, they must be related to somewhere, those set of questions. So what are current emissions? The Stern report, have any of you here heard of the Stern report? It's quite a few. It was a very influential report, came out in 2006 by a man who did a fantastic job in lots of respects. And I think the section he wrote on discounting rate was very brave. I mean, he's an economist, quite an orthodox economist, taking on the concept of discounting, how it is used and abused by other economists for looking at these sorts of issues. That was brave. But the numbers in it, other than the page numbers, I think are really dodgy. And the reason I'm going to say that, Stern came out in 2006, and they were not short of a few pounds to write this report, and they were not short of researchers to help them with it. The growth rate he assumed between 2000 and 2006 for CO2e was 0.95% per annum. But actually, the report came out in 2006, and all the data was available to show the real growth rate was 2.4%. Now, that's not an error it's not a prediction that's gone wrong. That is an error in the actual bothering to check the data. Now, that's reasonable. One person makes an error. We all make errors. But why is it no one heard about it? Now, that's an error of 250%. That's a fairly large difference. And I have another plot, which I'm not going to go into now, just shows the cumulative impact of that over a very short period of time fundamentally changes the conclusions of this report. So if you played that out, you would end up with a very different outcome from the Stern report, and that was a very influential report globally. And what I find most disturbing about that is you heard nothing from the scientific and the expert community. Now, not all scientists work on this stuff, but there are quite a lot of the integrated assessment models do cross over between the science, the economics, the engineering and the economics, and the social scientists, and you heard nothing from anyone about this. At that time, one of the most influential reports with a massive error in it, which had huge implications for its conclusions, and yet we didn't say anything. And that's partly because we liked the conclusions, because it fitted at that time with a political narrative that we weren't going to question. So what about the growth rate till peak? Now, this is changing, but until recently, virtually all scenarios that were produced, low-carbon scenarios to be advised in governments, assumed growth rates at about 1% to 2% per annum, which was far below the growth rate we already had, and there was no reason at the time to think that was going to change. So I'd say it's been growing at near 3% per annum. So we not only sometimes have massaged the historical data, but we're not prepared to recognise what the great growth rate is today. And we know we're doing this because the repercussions of taking the real data, the real growth rates, are very hard for us to then pass on back to our political paymasters. When do emissions peak? Now, this is stuff I'm going back through now, so this is slightly out of date, but this is still, I think, fairly helpful. Virtually, until very recently, virtually every single integrated assessment model, they're the models that advise governments on this, peaked emissions between 2014 and 2016 globally. Now, I know a lot of the people that wrote those, and no one thought that was viable. I've spoken at the Hadley Centre in the UK, at numerous government ministries with the people there, and no one thinks that a viable date. And yet, the Committee of Climate Change in the UK has 2016 as the date it uses for advising government. And government has taken that advice and built its budgets on the idea of a 2016 global peak. But there are numerous academic reports out there that were published between 2008 and 2011 that had emissions peaking between 2014 and 2016. And the reason they're doing that is if you peak the emissions later, you blow any decent budget. So there's a way that, even if it's not necessarily always a conscious decision, we always are undermining or underplaying the severity of the situation. There are numerous papers out there by Stern, Els and Van Vuren, and lots of other institutes out there as well that do this. Almost every single IIM had that in before, or had them earlier. There were quite a few papers that peaked emissions in 2010. And these are just some of the ones we're looking at the time, and so we're revisiting all of these now. But look at this. I mean, this Ackerman's paper, 2009, that has policy recommendations, peaked emissions the year later. Yeah. Hume, published 2010, peaked at the year. Now, that's getting quite challenging, but not quite as challenging as the paper from Hansen and his foil, Nordhaus, both both make very interesting contributions. I'm a much greater fan of the former than the latter, but these papers came out in 2008 and 2010 and peaked emissions in 2005. Now, that's even more challenging than the mitigation challenge at the moment. You need a time machine for that. So, but we've repeatedly done this as an academic community. We've underplayed the severity at these 3 levels so far. What about the reduction rates? Well, and I'm going to be slightly pejorative here, but every single IAM, every single one that we've come across, reduces at a rate of 2 to 4% per annum, occasionally touching 5. And these are all the ones that aimed at 2 degrees C or thereabouts. And that's a rate of reduction that's determined by these things people called economists, or I prefer astrologists or numerologists. And I do particularly mean here, for people, this is not the right terrain that they should be speaking about here. This is a terrain that is different to their theoretical background. For neoclassical Chicago and other sort of market-based economists, there are other schools of economics, like ecological schools of economics, institutional economics, that think of these things differently. But the ones that dominate policymaking at the moment are the neoclassical economists, and they've made this statement that reduction rate is set in stone, and therefore we can't question it. That has fundamental repercussions for why we have to modify everything else. So there's some real concerns about that reduction rate. I'm not going to go into the flaw now, but the negative emissions are interesting in that every single integrated assessment scenario that we can, these are the new review we're just doing at the moment. We're trying to go through every single IAM scenario, the main scenarios that advise government. Everyone that we can find at the moment assumes geoengineering, adopts a technology that will suck the CO2 out of the air. Now, some of them are doing it as early as 2024, and other ones are doing it for 2070. And they have it in there because what they've done, they've worked out the price for it, then they optimize their model on the basis of the price. So the price of geoengineering in 2070 is in some of these things. Now, I've got no idea what that is, and nor have they. And we don't even know if these technologies will work. They all use the same form of geoengineering, almost always, which is BECCS, which is biomass combustion, and then carbon capture and storage in the output from those. But virtually every single scenario also uses a lot of the biomass for other sectors like aviation, shipping, and cars. The cement industry wants to use biomass as well, and you've got to try and feed 9 billion people possibly on a planet with the temperatures changing. So no one seems to be looking at whether actually you could do all of those things with the biomass. So there are real concerns about this. Again, I would say there's a systemic bias. That if one scenario has it, or 2 scenarios, that's fine. But if every single scenario assumes it to give you a nice politically palatable outcome, that is a systemic bias that we should be very cautious about. And what budget for 2 degrees C? Well, you can argue about that, and I'll touch a little bit on that later, but I simply use the IPCC ones. It's not my job to figure out whether they're correct or not. I trust the scientists that are doing that work, that's their best assessment, so I'll come back to that later. But also, I think this is an important one. We usually use the language of Annex 1 and non-Annex 1, which is the language from the Kyoto Protocol, the poorer countries and the wealthier countries, or OECD, non-OECD, that sort of split. When is it that the poorer countries' emissions are going to be higher than the wealthy countries' emissions? That's a really important question. This is taken from this is a little bit out of date now, but it's the United States Climate Change Science Program. And they used, this is the quote from them, a meaningful and plausible reference scenarios from a perspective of highly regarded integrated assessment models in which non-OECD CO2 exceeded OECD CO2. Now, this is a really important parameter when you think about it. That's the wealthy countries, emissions are going up like this, or probably almost flatlining, just slightly going up, and the poorer countries' emissions are going like that. But at what point do the poorer countries actually emit more than we do? And that's really important when you think about what's going to happen in the future. I'm not saying it as a good or a bad thing, I'm just saying as just an assessment of those numbers is really important. So when did this set of meaningful and plausible, highly regarded, which I think is a bit of an oxymoron, highly regarded integrated assessment models, when did they say they'd cross over? Well, the Minicam was 2013, the Stanford one was 2021, and MERGE was 2023. But the real crossover date was 2006, which was actually before the reports were published. Now that, again, is inexcusable in my view. And it's inexcusable that as a scientific community, and I don't just mean physical scientists, I mean the whole expert community around climate change, does not point these things out. That is another way that we massage the data, even if it's not deliberately done. We massage, and that massaging the data is too strong a term, we massage our sets of assumptions to fit within a certain set of politically palatable outcomes that we know we can't question. And I'm not saying we're doing that deliberately, but it is almost like an emergent conspiracy amongst how we're doing generating these scenarios. I think it's that strong. and we have to break away from that. And I've spoken quite openly about this before, including to many people who produce these scenarios, and there is some change, I think, in this now. There's a slow shift, not just from me, lots of other people. Scenarios are supposed to be plausible futures, a range of plausible futures. Doesn't mean they're likely, but plausible. They've got to make sense. Yeah, I would argue that a lot of what we have are simply hardwired runs of a whole set of unreasonable assumptions. So these aren't models in the way that Gavin was talking about models. These integrated assessment models, you basically set the assumptions, you write in the algorithms, you press the go button, hey presto, out pop your assumptions, pretty much. They're instructive circular walks, I think someone once referred to them as. So it's a very nice way of thinking of them. You learn a lot by doing them. The results should be put in the bin. So what are the things that they've been doing that are hardwired? Well, until recently, I would say that the historical emissions were not as they should be. They often actually ran emissions out from the 1990s. So they span the models up from emission data from the 1990s rather than looking at the real emissions data that is collected. So that was a mistake that was made. And it's a modelling mistake, that often approach to these things. Short-term emission growths, as a consequence, were often very significantly underplayed. The choice of peak year was Machiavellian at best, and certainly was dangerously misleading. The reduction rate was universally dictated by economists, and that has fundamental repercussions for the shape of those curves. Geoengineering is ubiquitous in all of them, pretty much. Well, it's ubiquitous, so it's in all of them. The OECD, non-OECD split has previously been muddled, and there are lots of very naive assumptions about very well-meaning scientists who think they know something about engineering, and then they assume these big bits of kit will be built almost overnight. You can almost see it in the models when suddenly CCS comes along and suddenly flies up like that, or nuclear power suddenly shoots up, or wind turbines suddenly shoot up. That has never happened when we've built anything before. There is no evidence to suggest that in engineering that will ever work, and yet it's just put in the models. So there's real naive assumptions about big bits of engineering kit that are in there as well. We have a magician's view of time. We think we can go backwards and forwards with it, and we think problems are just linear. Rather than actually they're not linear, they're much more complex than that. So the whole set of assumptions that I think are embedded, and I won't be quite clear here, I'm talking here primarily about the integrated assessment models, the scenario analysis, not about the fundamental science that actually goes into those things, but then is manipulated, if you like, by the other elements, the other disciplines that feed into that. But I think there's a really important question on this. Why is it that as scientists and experts, and I don't expect all of us to be able to do this, but why are we not blowing the whistle on these fudges? We've been doing this for a long time. Why does no one say anything about Stern? Why does no one say anything about these sets of unreasonable assumptions? Now, there's a few people speaking out, but very, very few. And it's true to say that some people won't know about these areas. I think there are a number of reasons. These are my thoughts on this, and there could be lots of others, and we probably all fit into one category or another of this, or collective of them. This is Thomas More's defense to Henry VIII. Silence gives consent. It didn't work for him. He still got his head chopped off, but he was saying broadly he agreed with divorce. By saying nothing, he managed to hold his moral framework to his religious beliefs in place, and hoped he would not get his head chopped off, but he was unsuccessful. But that's quite a common sort of view, that if you sit there and say nothing, unless you've got a gun at your head, but if you haven't got a gun at your head, then probably you are effectively giving consent to something, if you know about it and you've thought about it. There's also the idea of a conspiracy of silence, that we could be, as a research community, we don't agree with what's going on, but we really don't want to bite the hand that feeds us. And I think there's a real case of that. I have seen that. I know of that with colleagues, very close colleagues I work with at many institutions, not just the one I'm at now, in terms of their relationship with the research councils who provide us funding. We know the sorts of things they need to hear, so the language of growth is paramount in all of our proposals nowadays. You have to write something about economic growth, how it will help economic growth. The Hadley Centre has recently got one of its major scientists. Her new title is Head of Innovation and Growth. She's a climate modeller. Head of Innovation and Growth. And why on earth would you ever accept that as a model, as a title for one of your modelers? We are ignorant of some of the fundamental implications of our research. That's another case, and that's not unreasonable. I mean, if you're an expert on cloud condensation nuclei, you're not going to know a lot about the sorts of stuff that I'm talking about today, and I don't know a lot about their work. So that's not unreasonable. We're all ignorant of some other areas. Or there's the other one that we just don't care. And actually, I've spoken to some scientists that are like that. I mean, they enjoy their work. They're in this area because they're scientists. They love doing scientific work. They don't really give that much of a damn about the bigger systemic implications of their research. It's engaging. It's interesting. So yeah, and also, of course, if you ask these sorts of questions, if you think about these things, it may ask some very difficult questions about our own lifestyles. Well, none of us like that. So we'll always try everything we possibly can. and try to rationalise it out to ourselves as to why we don't want to ask these questions or think about these issues. And I'm just the same as everyone else. We're all part of this, but I think to recognise it, to be reflective, might help us think about these things going forward. Beyond that, I'd say 2 degrees C is much more deeply embedded in how we think about climate change. Here are some quotes, and I have lots more from this as well, but these ones I've okayed with the people that I'm using their quotes from. This is a senior political scientist, and I could have put a senior scientist up from here, from one of the major modelling centres, but I haven't. But I could have put them up. This was after a discussion at a seminar on a scientific seminar, and I was sat at the back with this person, who actually is a friend and a colleague, and he's very influential in the UK. Too much has been invested in 2 degrees C for us to say that it's not possible. It would undermine all that we have achieved. It'll give a sense of hopelessness that we may as well just give in. So my question was, well, are you suggesting we have to lie about our research findings? And his response was, remember, these are all quotes, which I have checked back by him, well, perhaps just not be so honest, more dishonest. Now, this person is heavily engaged in politics, but so is the next person. This is a very senior person who was previously very high up in the IPCC, and at the time was a government chief scientific advisor. I won't mention who they were. We can't tell them, the ministers, the politicians, it's impossible. And this person, I won't even mention their gender, but this person actually thought it was impossible, 2 degrees C. It said that repeatedly to me and to others. We can say it's a stretch and ambitious, but with political will, 2 degrees C is still a feasible target and probably good for economic prosperity as well. So that's a very senior advisor to government. And here is the, again, I won't name them, I've deliberately taken out which COP it was now, but a government minister, the minister, there haven't been very many yet in our Department for Energy and Climate Change, because it's quite a new department, so you can make a bit of a guess as to who it is. But the day before attending one of the COPs, I had a meeting with him for 20 minutes, me, him, and a minder. And our position, his statement was, our position is challenging enough. I can't go with the message that 2 degrees C is impossible. It's what we've all worked towards. So you start to see why, as a scientific community, as an academic community, as an expert community, we are flavouring our work to fit within this sort of view. We've all come round to this way of thinking. We daren't step outside of this. It's like Albanian pyramid selling. You know, we daren't step outside of this anymore. No one dare really question the almost fraudulent nature of the venture that we're engaged in. Not the climate change, not the science, but actually we are underplaying the severity of what that science implies for what we need to do in our society, because it is very uncomfortable. So where does that leave us all? This is where some new stuff from last night, I think. Anyway, policy is dominated by long-term targets. So this is stuff that you're all probably quite familiar with. We hear about these reduction rates. This is from the UK, it could be from the EU, and we hear these things repeatedly. Large reductions by not in my term of office. So we all like that. The politicians love it. We can rely on the technologists to solve the problem with wind farms or tidal schemes or geothermal or CCS or whatever it might be in 2030 and 2040. So we all like this, but it has no basis in science. It never has had any basis in science. It's got nothing to do with temperature. The IPCC make very clear that it's the cumulative emissions that matter across the century. If you're looking at the temperature within this century, towards the end of the century, it's that total amount of emissions that we put out. They provide carbon budgets now, which are incredibly helpful. Myself and colleagues have been working with them for years, but it's really helpful now to have them ones from the IPCC, because they're much more authoritative than the ones we'd been using before. And it's fair to say there are lots of uncertainties with these budgets. You mustn't get, Gavin and I were talking about this yesterday, what you've got to be very careful about is not just assume that if it gives a budget of 1,340 gigatons, then the 40 gigatons is absolutely essential. It can be a bit more, it can be a bit less. There's some flexibility in these things. But nevertheless, it's a really helpful policy tool. They provide different CO2 budgets for different probabilities. And this is a table taken from the synthesis report, so which is a very relatively straightforward report to read. The last one from the IPCC, which I think was November. November last year came out. And in there, for 2 degrees C, to stay below 2 degrees C, they give a range of probabilities. They also give a range of probabilities for 3 degrees C and a range of probabilities for 4 degrees C as well. They're a little bit confusing in the reports, particularly the first set of reports. They're a bit clear in the synthesis report, but they're still in there enough for us to understand them. And they give you the range of budgets here. So we've got between 2011 and the end of the century, you've got 1,000 billion tons, a lot of stuff, a bit more than a lot of stuff, and a lot and a half of stuff. So that's the sort of range you get for different probabilities of 2 degrees C. Now, I work on energy. Energy is my main focus. So the first thing I want to think about that is, well, yeah, but that's CO2, and that's a lot of other issues involved with that. So we need to note, firstly, that since 2011, which is only a few years ago, we've emitted just under 150 billion tonnes of CO2 since 2011. So that's 15% of our budget for a likely chance of staying below 2 degrees C. 15% of our budget blown since 2011. You then say, well, how much are we going to use from deforestation and land use changes? These are some work that we did previously back in 2008, revamped it in 2011, and talking again with Eric, we think we're going to have to revamp this on some new data, which actually is slightly more pessimistic than our newest work on deforestation, which trying to suggest it was probably going to be less than that. But something like 100 gigatons, 100 billion tonnes of CO2 will be dumped into the atmosphere from land use changes, principally deforestation, across the century, and most of that occurs early on. The cement process emissions, which are pretty poorly captured in almost every scenario we can find out there, and cement is one of the most used materials. The cement industry say it's the most used material next to water on the planet by humans, and it goes into everything. Every building in Iceland seems to have a lot of cement in it. Your roads will have, power station foundations have. Everything that we do pretty much in big infrastructure requires lots of cement, and there are very few alternatives to it. I mean, there are no alternatives to it at scale. You can tweak some of the things, some of the constituent parts of it, and you might be able to use some wood in some examples. But nevertheless, cement is paramount to how we imagine industrialising the world, for the poor parts of the world, and for moving to a low-carbon future for power stations and so forth. And our 150 gigatons is very optimistic there. That assumes a lot of carbon capture and storage and a lot of other what's called clinker substitution in that cement process. You add all that together, that's 400 gigatons just blown of that budget away from your energy. So you start to look at those numbers, and they get revamped down at 600 gigatons, 900 and 1100. Now, these probably don't mean a lot to you unless you're like me, you spend your whole time messing around with these budgets. But you can then do something with those. If we imagine that the poorer parts of the world, the non-OECD countries, if they could then peak their emissions by 2025, and we all know that's massively challenging, but it's just about viable. And perhaps if we in the West showed some examples of doing something genuine about climate change, they might actually consider doing some of these things. But China's talking about 2030 peak. 2025, some Chinese academics, they think is viable with a relatively flourishing economy. But if then they came down at an emission reduction rate at 6 to 8%, which is a huge rate of change, twice the level that people say is possible with economic growth, if they put those two together, that would be about 700 billion tonnes of CO2 across the century. That means that already the likely chance of 2 degrees C is blown. Remember, that was 600. So you already have blown the likely chance. That's without any emissions from us. That's assuming we switch the lights off now. In fact, we switched the lights off in 2011 and our fridges and haven't flown or had stuff come on ships or anything else and done no emissions since 2011 because we're revisiting this now with the later data. And the budget's gone. So even if you went to a 50-50 chance of 2 degrees C, and being as we've defined this as dangerous, imagine what that means. That means, I think I used the analogy the other day, that's half the time you cross the road, you have your eyes closed. Crossing the road with your eyes closed is dangerous, but it's only dangerous to you. The problem with climate change is dangerous to the planet. So we're taking this experiment at the planetary level, and we're prepared to say to the planet, close your eyes half the time when you cross the road. We would never do that with any other sector. You wouldn't do that with a plane, a 50-50 chance of it falling out of the sky, or a nuclear power station in 30 years of life, a 50-50 chance of it going bang. You wouldn't do that, but this is only the planet, so that's fine. So a 50-50 chance. Then we'd have to have about a 10% reduction in emissions in the wealthy parts of the world. Now, we're revisiting this. This at least is really important here. I think that number, we're careful when you're on film saying these things, the sense I'm getting from the numbers we're trying to pull together on this, that's probably going to be near a 15% per annum reduction rate. So a massive reduction rate every single year from now. So that's a 40% reduction by 2018, there or thereabouts. And they're just guides. Imagine your own life and cutting your energy consumption by 40% by then. 70% by over the next 10 years, and they're virtually eliminating all of our fossil fuel use, not just from electricity, which is easy in Iceland, but from everything else, from all your cars, planes, ships, or my cars, planes, ships, all of our appliances and so forth have to be supplied by very low carbon electricity. These are revolutionary reductions that are considered impossible with economic growth. That's a really important part of that. You take this bit out of the equation, of course we can't question that because God sent us that. I mean, this is much more reliable than physics. Economics always trumps physics. At least it doesn't in our political world anyway. But it's also worth bearing in mind that the only example we have in this sort of direction was the collapse of the Soviet Union, which saw about a 5% per annum reduction rate for 10 years. And that was not through judicious climate change policy. And it was disastrous for lots of people in Russia and other parts of the Soviet Union. It was very inequitable. But that's the only time we've seen these sorts of reduction rates. And they were still less than half of what we would need. So that looks impossible, and Gavin and I have been arguing a bit about this the last couple of days or so, but I would argue the other version's impossible as well. The 4 degree C world that Eric was describing earlier, that's impossible. So in that sense, the future is impossible. The future is revolutionarily different from where we are today. So let's not pretend we can drift our way out to the future, do nothing about mitigation, and hey, nothing will really happen. If the science is in any way correct, and there's nothing that suggests that it isn't, then we are moving towards a different planet, a different place. And that would be revolutionarily different from where we are today. So there is not a no-change future. Whatever we do will be radically different. One of them is we can actively choose and aim to go down the mitigation route, which will be very different, but we can choose that. We have some agency. We can describe what it looks like. The other one is we get hit by the impacts of doing very little. Now, we think we'll escape those because we're in the wealthy north and we can do something about it. The poor people in the southern hemisphere will die, a lot of them. That's the adaptation technique that they will be adopting. And when we talk about these things, about people muddling through, what we mean by that is the poor will die, or large numbers of them. So we have to bear that in mind when we think about what are the impacts of are we prepared to make these sorts of changes? Now, this is all fairly despairing stuff. I thought this was slightly more upbeat than the other talk, but perhaps it's not. I may not be doing this one again. The question then is, have we got the agency, have we got the ability to make the sorts of changes that are necessary? Now, I think we're just on the cusp of this, and I touched on this the other day, so I'm going to go through it quite quickly now. I'm going to touch on 2 of them. On equity, I think there's a message of hope in that, though it's a challenging message. On technology, but mostly on the demand side, and I'm not going to go through this one today, but I think growth is an incredibly dangerous proxy. And it's been very dogmatic as well, but dogmatically obstructive in terms of thinking about the sorts of things we need to do. Because we cannot ever question this concept of growth, we can't even break it up to talk about growth that might be good for some parts of the country and not so good for other parts of the country. You know, issues of equity and distribution, they're not there for us to discuss. We're not allowed to do that. But I think if we could actually do that, that would help us a lot thinking about climate change. I'm going to talk about the first 2. Who are the emitters? Well, there's 7 billion people on the planet. We're aiming up towards 9 billion. But if you're trying to put a policy that's going to affect all 7 billion people, that's going to be a little challenging. We're all culturally different. We have different levels of well-being and live in different parts of the world and different governments and so forth. Using Vilfredo Pareto, an Italian political economist from the 1800s, broadly 80% of something relates to 20% of those involved. Now, that looks to broadly hold for emissions. It would be interesting to do a quick poll in this, get everyone to write down their carbon emissions in this room very roughly for how much over the last year, and I would guess you would find that sort of split. And if you go into the 20%, the ones that emit most, I think you'll find it again. And we think you'll find it 3 times, though this is very hard to get the data on this because there's lots of very complicated methodological problems in doing this. But what that does suggest is that if you run that purely mathematically, 50% of the emissions come from 1% of the population, which makes it much easier for policy because you haven't got to aim the policy at all the population. The problem is these are the policymakers. They're us. They're us, our friends, our families. They're all people that look like us. So we're very unlikely to make those sorts of changes. We much prefer other ways to fudge the system. And more realistically, I think it's just as a guide. Again, these numbers, like the budgets, are just guides. I think it's fair to say something like 40 to 60% of the emissions come from 1 to 5% of the population. So a relatively small chunk of the population are responsible for most of the emissions. And of course, that fits with the recent data from Oxfam on wealth around the globe. Now, again, there are lots of methodological issues when you look at these things as to quite how they've worked out. But it does suggest large amounts of emissions from small percentages of the population. And who's in that group? Well, we all know who's in that group. I am, Gavin is, all the folk came from the World Bank. We're all in that group, and probably everyone else in this room is, or at least if you're not in it, then you'll be aspiring to get in it. Universe is always full of people aspiring to get into the 1%. So every climate scientist, any pontificator, actually the skeptics seem to have much, much higher footprints than most of the climate scientists, because quite a lot of them are very wealthy and they always fly business class, which doubles your emissions. So journalists, pontificators, basically any academic that's part of the current global academic system, which means you have to spend most of your life on a jet. Anyone on a long-haul flight every year, it's not all about flying, but they're good. People who fly a lot generally use taxis. People who fly a lot and use taxis generally have quite big houses and reasonable-sized cars. That's not always the case, but it broadly holds. If you look at the income of people that fly, they're way, way above the averages in their own country, and let alone globally, of course, where most people globally never fly. Mitigation is not about, this is for 2 degrees C. It's different for 4 degrees C because the budget's bigger. For 2 degrees C, for the range of budgets that are there, mitigation is about the few, not about the many. Impacts are about the many, but mitigation is about the few. It's a consumption issue, not a population issue, and that's a really important, I think, sort of take-home message, if you take the rest of my argument as having some validity, is that if we're going to talk about 2 degrees C, we have to reduce our emissions so rapidly, even with the lower probabilities of 2 degrees C, that actually the poor people cannot become wealthy enough to live lives like us in the time frame that's necessary. So it actually comes down to the fact that it is down to us and how we consume things. Now, if you talk about 4 degrees C, more of those people will become wealthier in that time frame. But 2 degrees C, the time frame is so tight, it's about us. Technology, I'm just going to touch a slightly different example to the other day. This is just using the electricity system, and this is really done for the UK, or not an Iceland type electricity system, but you get the purpose, I think. If you think of refrigeration, if you want a refrigerator, what you require is some electricity, and if you require some electricity, you require transmission and distribution lines, and if you require those, you need a power station, and then you need someone else. And this is not for you, obviously your bit here, the end's a bit different, but you require some Venezuelans or Australians to dig up the coal or get the gas from Qatar and bring it over in a ship or something. So you require all of that to keep your fridge going. If you start to put some units on this, 10 units of useful refrigeration, whatever that might look like, you're going to, the refrigerators aren't particularly efficient in doing what they do, and it's worth bearing in mind that this is sort of built on the idea that an A++ fridge uses 80% less energy than an A-rated fridge. So there are massive changes you can make at this end. The transmission network, the UK one, and I think most of the European ones, which are high voltage AC ones, I don't know what your voltages are here. The pylons are smaller, so I'm guessing it's not so high voltage, but I'm not sure. Someone might have to tell me. But the high voltage stuff, 250,000 volts or more, only talking about 2% loss in transmission. The distribution lines, the ones that come under the city streets, they have a much higher loss, maybe 5 or 6% loss. So the big loss in these things, mostly through waste heat, or almost all through waste heat. Power stations, thermal power stations are very inefficient. Most of the energy in a power station goes up the chimney. You put in, with coal, you're going to lose 65% of the energy up the chimney. Put a CCS plant on it, you're probably going to lose 75% of the energy up the chimney one way or another. Gas is going to run at probably 50% of the energy goes up the chimney. Maybe you might get slightly better than that, but not much. So power stations are, the very nature of the Carnot cycle, they're constrained by laws of physics, and they can't be made much more efficient. You can use the waste heat, which some parts of the world do, much of continental Europe does, the UK doesn't. And then you've got to get the stuff out of the ground and carry it over. So what I'm saying here is that the efficiency opportunities here are enormous, and we need to focus much more on this than this. This is really important. We are focusing on this, but we almost ignore this part. There are huge opportunities for doing massive things here at virtually every single sector. But always bear in mind, the big problem is that every pound that we spend at a system level pretty much disappears back into the system to be spent as another pound on fossil fuels elsewhere. So you have to have mechanisms that stop the rebound. So efficiency itself has never brought our emissions down, not at the system level. But that's not to say it's not a good thing. It's really important we do it. But we must be cautious about the fact that we'll rebound. We'll buy a jet ski or take another holiday if we save money on our energy bills. But what it also does, it extends the window for building low-carbon energy supply. So it gives you a bit longer to build the wind turbines, the tidal Bauer schemes, the geothermal plants, the CCS plants, the nuclear fission plants. These things are all very low carbon. And it extends the window for that, but not by much. And to summarise, these are very uncomfortable implications from what I would argue are a relatively conservative set of assumptions. This isn't using data from Friends of the Earth or Greenpeace. I mean, that may be very valid data. This is using IPCC numbers and the basic data that we collect by governments. That's all. And adding them together. If industrialising as in the non-OECD countries, if they peak by 2025 to 2030, if there are massive reductions in deforestation and food emissions, if there are no tipping points out there, discontinuities that Eric spoke about earlier, and the higher the temperature goes, the greater the chance of those things occurring. But there's a lot of uncertainty around them. If the feasible reduction rates of 3 to 4% per annum with economic growth are achieved, then 2 degrees C stabilisation is virtually impossible. So if we do all the things that we say we can do, then 2 degrees C isn't viable. And we're going to be heading towards 4, 5, 6, whatever it might look like, towards the end of the century, that sort of period. That's looking increasingly likely. Now, the bit is that's virtually impossible. It doesn't say it is impossible. We can still do something about it. But we have to do much, much more than the things that we're prepared to talk about at the moment. We have to be able to question the things that we're not at the moment even allowed to speak about. So for policymakers, the challenge is, in that sense is simple. We have to avoid 4 degrees C, that sort of pathway that points in that sort of direction. We have to avoid that at all costs, and that requires us to make almost immediate changes. And for 2 degrees C, we need a 70% reduction in our emissions over the next decade, there or thereabouts. These are just guides to policymakers. But actually, those emissions primarily come from a small percentage of the population. So think about that when we're developing our own policies, what that might look like. Low carbon energy supply is too little too late in the West or the North, however you might view these things. It's still necessary. And as an engineer, I'm really pleased because I find that side the most interesting bit. I spent some time in a geothermal power station here yesterday, and it's the most enjoyable, other than the Northern Lights, probably the most enjoyable thing I've done in Iceland so far, because I like big bits of kit like that. They are needed, but they're not enough. The principal response is to reduce energy demand now. And the dominant policy instruments, which we can discuss maybe later if people want to, of carbon trading and prices, they are simply misguided for this sort of scale of challenge. They simply cannot deliver, and in fact they are part of the problem, that we thought these marginal tools can deliver non-marginal outputs, step changes. We need something much more fundamental than that. Headline messages, change our behaviour today. We can all do that. We can all make changes in our behaviour every single day to reduce our emissions if we think it's important, both as producers and as consumers. We need to consume less anyway, and again, many of us can do that. Those of us that are already very wealthy, people like myself, I can consume a lot less. I can make that effort. It's not that hard for me to do, really, if I thought this was really important. We need to improve end-use efficiency. We need to do that now and over the coming decade. And we need to move to low and zero carbon energy supply, which will take a little bit longer, but we don't have much longer to do it. 2025 to 2040. 2040, really, we need to make sure that everything is very low carbon on the energy level. And that means virtually zero, because even a small amount of CO2 emissions has a real implication when you start to add that up over years. Some non-scientific messages. We need to lead by example. We do not have examples. Everyone thinks it's the system's fault, that some benevolent dictator in government is going to pass down policies that are going to bring this about. That's not how societies have virtually ever worked, certainly democratic societies. It is a partnership, an emergent partnership that is never that clear how it works. We all need to be leading by examples, trying to do those small things in our own homes, as well as in our companies, institutions, and lobbying governments and so forth. Don't be the exception. Every sector I'm involved with, I've done a lot of work on cars, particularly planes and ships, they all say they're an exception. But I don't know any other sector that doesn't think that. The scientific community thinks it's an exception, should be allowed to emit more than everyone else. The business community says that. The tourist industry says that. Every other sector I've engaged with says it's the exception. I've not met the person that's going to compensate. I was thinking maybe they're a small pet shop in Rotherham that's going to compensate for world emissions, and the rest of us are all exceptions to the rule. Don't hide behind or blame others. The UK blames China. China blames the US. Everyone's in this bloody blame game. So we need to have the courage and the tenacity and the integrity to stand outside of that and start to reflect on our own role in this, our own role of our society, our family, our friends, our institutions. Consider the system as a whole. The US always says, well, look at that shale gas, great stuff, our emissions have come down. The Americans now are selling the coal they weren't burning. The coal they weren't burning came into Europe. Europe and Asia emissions went up the year that theirs significantly went down in the US. I've done a lot of work on this interplay between these two. And if you look at the US emissions, actually, the US emissions from the amount of fossil fuels they produce has gone up. So look at the system, don't look at the bits. And the bits are important, but you've got to look at the system as well. The bits are essential, but you must also look at the system. Acknowledge it's not going to be easy. It's often going to be very challenging. I did have on there, it's going to hurt. And for people like me and for some of us here, it's going to hurt. It makes it very difficult. We can't see our families so often, we can't travel as often, we can't buy as much stuff, all the things that we think make us very happy and content. Be courageous, both as leaders and as citizens. Mitigate for 2, plan for 4. But we mitigate for this. We really need to be doing that. But we also have to think we are likely to fail. So finally, I'll go back to my opening statement. This is, taken from that paper. I'll finish it off again. This is not meant as a message of futility, though I think it might come across like that. But a wake-up call of where our rose-tinted spectacles have brought us. Real hope, if it is to arise at all, will do so from a bare assessment of the scale of the challenge that we now face. And I've tried to sort of highlight what that looks like today. So you'll be pleased to know that was the final slide. Thanks very much.